This is Mr. Martin. These are video notes for Pre-Calculus Honors. We're still on section 6.5. This is day 2. This is actually the first video of 2 videos for day 2. And we're talking about complex numbers and the trig form of complex numbers, sometimes called the polar form. So again, lots of vocabulary that you have to try and keep track of, but a lot of the concepts are really very similar to things that you've done in the past. So the first thing we're going to look at are powers of complex numbers. So we're going to look at our complex number in polar form or trig form. So again, really in our standard form this would be a plus bi, but we're going to look at these in trig form. So we've got z to the first, which is r times cosine theta plus I sine theta. And then we've got z to the second. It's going to be r cosine theta plus I sine theta times r cosine theta I sine theta. And what this ends up simplifying to is cosine 2 theta plus I sine 2 theta, and I'll show you how that works in a second. We've got the r times the r. That gives us the r squared. And then we have these two quantities that we have to FOIL out. So I'm going to show my work up here. I've got cosine theta plus I sine theta times cosine theta plus I sine theta. So I have cosine times cosine is cosine squared theta. And then cosine theta times I sine theta is plus I times cosine theta sine theta. And then I've got another one of those from my inner, so that's I cosine theta sine theta. And then I sine theta times I sine theta. If you remember, I is the square root of -1, so I squared is -1, so that's going to be minus sine squared theta. So I'm going to highlight two different things here. I've got a cosine squared theta minus a sine squared theta, and over here I've got these two things, which is going to simplify to, in the middle here I've got 2, let me rewrite that, sorry. So I've got I times 2 cosine theta sine theta. So if you remember back to our double angle formulas, cosine squared theta minus sine squared theta is going to be cosine 2 theta. So then that's where our cosine 2 theta comes from. These two things go together to make cosine 2 theta. And then this part over here, 2 cosine theta sine theta, that's going to be our sine 2 theta, and then we have the I that goes along with it. Alright, so moving on to the next one, and again, if you have any questions, just make sure that you write them down and ask them ask them the next time you see me. If you're watching in class, you could just ask right away. So for z cubed, we're going to have z squared times z, and if you want to go through all the algebra, feel free to do that, but I'm just going to go ahead and show you that we're going to have another r, so it's going to be r cubed, and then when we simplify the multiplying out of all the trig functions, we're going to end up with cosine 3 theta plus I sine 3 theta. Again, if you want to work out the algebra with the trig functions, feel free to do that. And then for z to the fourth, if you kind of can see the pattern here, it's going to be r to the fourth times cosine 4 theta plus I sine 4 theta. Okay, and then if we carry this on to z to the n, we would have r to the n cosine r theta plus I times the sine of r theta. Okay, and this formula that we have here for our complex number raised to an exponent is actually called de Moivre's theorem. Alright, so we've got z is equal to r times cosine theta plus I sine theta is a complex number, n is a positive integer, then z to the n is equal to, here's my complex number raised to the nth, which turns out to be this. Okay, so here's a formula that you can use anytime you're trying to raise a complex number to a power. So let's take a look at using this in an example. We're going to use de Moivre's theorem to find negative 2 minus 2 root 3i raised to the third. So the first thing that we're going to do is find r. So we know r is going to be the square root of negative 2 squared plus negative 2 root 3 squared. And this turns out to be 4. So that's negative 2 squared is 4, and then this is going to be 4 times 3, which is 12, so 4 plus 12 is 16, square root of 16 is 4, and then we need to find theta. So theta is going to be the tan inverse of negative 2 root 3 over negative 3. These are going to cancel over negative 2, sorry, that's negative 2. So tan inverse negative root 3. I know that I'm in the third quadrant, so I need the pi over 3 that's in the third quadrant, so that's going to be 4 pi over 3. And we also have that our value of n is 3. So we've got everything we need to plug into our formula. So I've got z cubed is going to be 4 cubed times the cosine of n times theta, so that's 3 times 4 pi over 3, plus I times the sine of 3 times 4 pi over 3. Alright, and then 4 cubed is 64, and this is the cosine of 4 pi, the 3's cancel, plus I times the sine of 4 pi, and this becomes 64 times cosine at 4 pi is 1, and the sine at 4 pi is 0 plus 0i, which just turns out to be 64. Alright, again, if you have any questions, I know the formula looks kind of scary, but once you get into it and start substituting values, it's really not that hard. You need to remember your unit circle. Alright, so go ahead and pause the video and work out this example, and then when you come back the solution will be there so you can check, and as always, if you have questions, make sure that you ask. So pause the video now. Alright, so here's the solution to the problem that you were supposed to try. You should have gotten 4096. Here's your value of r is 2. We know theta is going to be 2 pi over 3. Remember, this is a pi over 3, and negative 1 plus root 3i is going to be in the second quadrant, so we know it's got to be the 2 pi over 3. N is 12. Substitute everything in, and hopefully you got 4096. And again, if you didn't, make sure that you figure out what you did wrong or ask some questions. Okay, so next we're moving on to roots of complex numbers. So we want to look at f of x is equal to x to the 6th minus 1, and we want to talk about how many solutions does this polynomial have. Okay, and we're going to want to use the quadratic formula. But let's take a look at this, and let's change this to x to the 3rd squared minus 1 squared is equal to 0. So then we have a difference of 2 squares, and I can factor this to x cubed minus 1 times x cubed plus 1 is equal to 0. And now I've got a difference of 2 cubes and a sum of 2 cubes. So if you remember from algebra, this first one is going to factor to x minus 1 times x squared plus x plus 1, and then we have times, and the sum of the 2 cubes factors to x plus 1 times x squared minus x plus 1 is equal to 0. So then we have these four quantities that we can solve. From this, we're going to get that x is equal to 1. From this, we're going to use the quadratic formula, and we get x is equal to -1 plus or minus, and then I'm not going to show all the work here, but you could go ahead and do the quadratic formula. It's going to end up to be I times the square root of 3 over 2, so this gives us two solutions. And then from this one, we're going to get x is equal to -1. So we're just using the zero product property. Since we have four things multiplied together to equal 0, the only way to get 0 from a product is to have one of them be 0. And then solve this again using the quadratic formula, and you get x is equal to 1 plus or minus I root 3 over 2. And again, if you want to work those out using the quadratic formula, go ahead and do that. And you see that we get 6 solutions. Okay? And then some of these are imaginary, but we do end up getting 6 solutions. Alright, so with complex numbers, it's not possible to choose the positive root as the nth root of a plus bi, as is done with real numbers, because positive and negative, these don't really apply. They are not meaningful terms in the complex numbers. So for example, should 3 minus 2i be called positive or negative? Well, we don't really know. So what we're going to do is we're going to make every real number a complex number. So let's say I had the number 5. I could make this 5 plus 0i. Okay? And then if I had the number -5, I could make it -5 plus 0i. Alright? And then for each of these, I could find my modulus and I could find my direction. So for example, this one, I would have r is equal to 5, and theta would be pi. Because if I graphed it, it would be -5 in the real direction and 0 in the imaginary direction. So here's -5. That's where my point would be. Alright, so every real number is really a complex number. In the complex numbers, we would say that 16 has 4 fourth roots, because these are all the different ways that I could raise a number to the fourth and get 16. I know 2 to the fourth is 16, -2 to the fourth is 16, 2i to the fourth is 16, and -2i to the fourth is also 16. So those are all solutions to z to the fourth equals 16. But if we talk about real number roots, 2 is a solution and -2 would be a solution. But we would also say that in the real numbers, 2 is the fourth root of 16. So a lot of this is just terminology. If we look at another example, let's say we have z to the fourth is equal to 81, and we wanted to find the fourth roots, we would say that z is equal to 3, or -3, or it could be 3i, or it could be -3i, because these are all numbers that if I raised it to the fourth, I would get 81. Alright, so I think I'm going to end this video here, and I'll just continue it into the day 2, part 1, and then it'll be the second part of part 1, but because I don't want it to get too long. So make sure you're doing lots of practice problems for this stuff, because there's a lot of strange formulas and a lot of the stuff you haven't seen before, and we want to make sure that you're successful with it. So again, make sure you ask any questions, and we'll see you next time.